Good morning or afternoon, depends on where you are in the world. My name is Andy Deal. I'm the VP of Marketing for Saratech, and welcome to our webinar today. We have a special guest, Cat Pomorski from Markforged, and today Cat will be talking about successful metal 3D printing strategies. So for the next 45 minutes or so, we'll be talking a little bit about Saratech, the growth of 3D printing technologies, and then Kat will go over tips and tricks and strategy for making sure that you have success when it comes to 3D printing. We will also have a Q&A session at the end of the webcast, so at any time if you have questions, go ahead and type them into the chat box and we'll address them in the Q&A area. So first, I would like to share with you a little bit about Saratech. So at its core, Saratech is an engineering company. What we do is we help customers solve engineering and business challenges by providing software, expertise, and manufacturing solutions to optimize product development. Since 2002, we've been helping customers optimize their design, analysis, and manufacturing processes. Saratech is an award-winning solutions provider in the PLM space, and we earn the trust of our customers by delivering results and building resilient relationships. We're headquartered in Orange County, California, with sales and technical coverage all across the country. So I want to share with you an interesting stat. Based on a Wooler report in 2008, it shows that there's an 80% growth in the sales of metal additive manufacturing systems from 2017 to 2018. So why should this statistic matter to you? Well, first of all, it means that more and more companies are investing in this technology. So as a business, as a manufacturing company, you don't want to get left behind. 3D printing is a fast-growing industry, especially metal will play a significant part of manufacturing. So if you have not begun to look at 3D printing, and you probably are because you are on this webcast, but time to seriously take a look at how 3D printing and metal can be incorporated into your existing manufacturing processes. Before I pass it over to Kat, just a quick housekeeping question or slide. If anytime you have questions, go ahead and type it in the chat box, and at the end of the webcast, I will address them and Kat will answer your questions. And also, don't forget, after you log off the webcast, there's a short 5-question survey that pops up. It would really be great if you take just maybe 10 seconds to fill them out. It would help us out a lot, and you can also ask additional questions there in case you're too shy to ask in the webcast. So at this point, I'm going to transition the webcast over to Kat. Kat, you now have the screen.
Awesome. Thanks for the introduction, Andy. Hopefully everyone can see my screen. Looks good on my view, at least. Welcome. And so, as Andy mentioned, my name is Cat Pomorski, and I'm an application engineer here at Markforged. So we're going to talk about strategies for successful metal 3D printing. But first, I really want to talk about our equipment before we go in on how to design for it. So our metal printer is called the Metal X, and it is based on metal injection molding plus 3D printing combined. So we use something similar to a MIM feedstock, and this is a metal powder bound in a wax and a plastic, which allows you to form it, extrude it into the shape that you want to then have your final part as. This technology allows it to be more office friendly, a little more cost effective, and a bit safer than all of those powder techniques. So our process is called ATOM, Atomic Diffusion Additive Manufacturing, and you put your design, your STL file into our Eiger software. Our software will automatically scale it up about 20%. This allows to account for shrinkage that's going to happen during the sintering process. And then it goes into a wash to remove the wax portion of the binder and the sinter to remove the polymer portion of the binder, as well as to create your fully dense part. So yeah, you design your part that you want to come out, and then our software will automatically scale that up for you. So what does this look like? So I'm going to go kind of into like a more internal view of what's happening to our parts. So as you print it, you have all of those wax and polymer binders that really hold the part together before you actually get to the sintering step. During our printing process, we don't melt any of the metal powder, so we don't get that hot. But we do melt the binders to help create the green part, as we call it. So after the wash station, we have debound the wax portion of the binder. So we have the rest of the polymer holding it together until you can then put it into the sintering oven to start tacking those powder particles together, and then eventually getting your post-sintered dense part. So now that we've talked a little bit about that, I'm going to go through the steps that you need to take to really have a successful metal 3D printed part. So the first one is going to be meeting the economic requirements. Then it's choosing a part with suitable geometry, and modifying it or designing for additive manufacturing. And then you have to also plan ahead if you need to do any post finishing operations. So our parts come out at near net shape, and the tolerances are pretty good, but if you need something really tight, then you need to go ahead and plan for taking off that material post sintering. All right, so meeting economic requirements. I'm just going to go through this kind of briefly. So this is a cost comparison curve where so additive manufacturing are still going to be those high value, high cost, low production volume parts to make them very cost effective. This isn't the only thing that you think of when you want to 3D print a part. So we have these things we call secondary benefits, but sometimes they're even more important than just the cost and the time to make the part. So this can include, say, saving weight on a part that an operator is moving around, and anything like that sort. That may not be as cost effective, but it makes someone's life better. It makes parts easier to move around. You can create multiple parts into one assembly, kind of like our Stanley Black & Decker, which I'll show you in a little bit. And so another cool thing about our software is if you're interested in, if you have a metal part in your mind that you want to print, you can pop it in our Eiger software, and these part details tell you how long your part is going to take to print, wash, and what the material cost is. All right, so choosing the right part geometry. This is probably one of the harder steps to do. 3D printing is not good for everything, and I won't be the person that tells you that. Some things it's not great for is parts designed for other manufacturing process. So parts designed for metal injection molding, any sort of machining may not be great for 3D printing unless you redesign it. Because these parts were designed for those specific processes. So we always have to take that in consideration when trying to get your part 3D printed. Other geometries that aren't that great are any sort of off-the-shelf hardware that you can just buy cheaply at a store, or parts that are high aspect ratios. So either very thin, flat parts or tall, skinny parts. Anything like that may warp during sintering because you always have the factor of kind of heat and gravity acting on your part when it's in the sinter oven. But one thing you might be able to do is create tooling for all of these off-the-shelf parts and hardware. So it might be as simple as that. If you have something custom that you want to make, but our printer might not be great for it, you can always create tooling for that. Some of the well-suited geometries are any like castings, some machine parts, die-cast parts, anything that's a little like thicker in dimensions, but these parts still also may need to be redesigned for additive to get them to be truly successful. Granted, there are parts that you can just take from one process, put it on a printer, and you get it out the next day and you're good to go. All right, so redesign for additive. I'm a huge proponent for this. It's kind of difficult to do, but this is the Stanley Black & Decker part that I was talking about a little earlier. And so originally this part had a cast component and 2 bolts and just a regular plate. And so with 3D printing, we could create this part into one part instead of 4 different components. So this not only saved time, but it was also cheaper. And we used these like triangular or the teardrop shaped holes because it was self-supporting. And since this hole is curved, you wouldn't be able to remove the supports. So designing it with those self-supporting holes allows you to not need supports at all. So anything else? So design for additive manufacturing has its own design considerations that you need to think about when you're either choosing a part or redesigning it for 3D printing. All right, so we're going to talk about designing for printing first. So our process is an FDM style process, and you're going to go layer by layer till you get to your final part. So you have to think about how are each of these layers going to interact with the next one. So the part on the print bed right now looks pretty straightforward. That's absolutely how you would print it to get a successful print. But if you have a part with any overhang features, you have to think about how this part is going to be supported. So this part would definitely require supports that you would have to take off post sintering. And why we really care about that is parts that are in the Z direction that aren't touching any of the supports tend to have a better surface finish than those that are supported. Sometimes it's really important to have a lot of supports, other times it's not. I can give you some base details, but this process is very geometry dependent, and you're probably going to have to play around with it to really get to the part and the orientation and geometry that you really works for our process. So this is kind of an example of support material. Everything over the 45° from the vertical requires supports for both printing and sintering. Sometimes our part will generate supports that maybe not are necessary for printing, but they definitely are for sintering. Because again, if you think about it, there is that gravity heat aspect that goes into these parts that may cause it to, again, warp or sinter. So this is a little image of what our support material looks like. If anyone's familiar with our composite material or parts, we use same material like plywood supports, and we do kind of the same thing with metal as well. So we use the same material, just so 17.4 is our most common one, and then we also have a release material, and this release material turns to like a fine dust, which then allows you to tap out all of the supports post sinter. Also, we print all of our parts on a raft. This allows us to have uniform shrinkage and to make sure all of our parts shrink uniformly, so we can get you those dimensional, your part as accurate as possible. Another important thing is print orientation. Sometimes more supports are better, but you also want to make sure that your part has contact with the print bed. Again, if you have a tall, skinny part, it may warp during sintering, so you have to be cautious when you're printing kind of funky geometries. You want to make sure you optimize those parts and have maximum bed contact. And if you do have very critical dimensions, the XY dimensions tend to be a bit more accurate than the Z direction, especially if you're talking about holes that may have some force on them during sintering and may slump a little bit. All right, so design for wash. I wanted to put this in here just to draw attention to it, But a lot of the times we don't necessarily design for the wash step of the process because the sintering is the most critical step. 3D printing has been around for a while, FDM style has been around for a while, but sintering is definitely the more difficult part of this whole process. So if you design for anything, design for sintering. So the wash, what the liquid does is it removes the wax portion of the binder. So this wax portion of the binder has to penetrate through the entire part before it is done washing. So your very thick cross-sectional parts are going to wash much longer. But if, say, you were to add some sort of hole in your part or shell the part, kind of like the Eiger sample that I saw, you can decrease your wash time if that is a concern. A lot of the times, though, you'll have, since the wash process is a batch process, you can put like your longer washing parts in at the beginning of the week and your slower washing parts in at the end of the week, and then run a sinter run over the weekend to make sure that all your parts are fully washed. All right, so design for sintering. Some of these considerations include like filleting sharp edges. This can prevent warping. These sharp edges can act as stress concentrators, which can make your part not be completely accurate. And then also supporting top-heavy cantilevers. So I was kind of mentioning the high aspect ratio parts, and so some of these, again, more supports are necessary. So the part on the left with the X, it probably wouldn't sinter very well and may collapse because it is very top heavy. And if you think about the heat and you have this like metal sandcastle, that may fall apart if it's not supported correctly. So just adding in your own support, something like that, may help it sinter successfully. And so I'm going to keep reiterating it, but you just have to be wary of high aspect ratio parts. Again, put the critical dimensions in the XY plane. Chamfering your bottom edges of your part may also help it shrink more uniformly, and you won't get any dimensional distortion from anything. Also, sometimes it's helpful to split complicated parts, and so splitting these parts may be either helpful to get it to fit into the sinter one, or it could help in your any sintering. So again, if you have that high aspect ratio part and you just have a top heavy part, you can, instead of trying to add more support material or a cantilever, you can always split it up and then bolt it together later. All right, and so the last step is planning for finishing operations. So first, in the top left corner is the no finishing, so that's how the part comes directly off of our printer. One cool thing that you can do, because our printers are in the green state, is to wet sand them. This is great to smooth out all of the surface lines that you may get in the part because it is 3D printed. But you may sacrifice dimensional accuracy a little bit because you don't really know how much material you're taking off of the part itself. This is more for if you need just a really nice surface finish. So the next one is the post-sinter sanding and polishing. Again, this is great because you can a little better control your part and can get a nice clean surface, but you may again not be able to hit the dimensional accuracies that you would if you needed to post-sinter CNC machine it. So that's the final picture. And so this really shows how nice our parts can look if you do need to hit tighter tolerances to just quickly CNC up the surface to get those. And then just a little summary. So I really talked about understanding the 3D printing process, trying to understand how the process works so you can design effectively for it, talking about the ROI and how to decide whether you're going to 3D print a part, and then talking about the right part geometry and redesign, and then finally plan for post-processing. And then I'm going to pass it back out to Andy for any questions. I'm more than happy to take.
We have a bunch of questions that came in during your presentation. So I'm going to go ahead and ask him now. And also at the same time, if you have questions, please go ahead and type it into the chat box, and we'll go ahead and get those answered for you. So give me 1 second. But one of the questions that I had came in from Paul is about support. It says, with the metal, doesn't printing the support and raft in the same material make the part more expensive? Wouldn't it be more cost effective to use a cheap material for support?
Yeah, so the good thing is we don't print a lot of support material typically, but if you do have a part that requires more support material, it will be a little bit more expensive. We've been looking into other options, but for right now, that works the best. The reason we do that is because both the support material and the raft will all shrink uniformly. And if we change the support material, you may not get that uniform shrinkage, and you could cause your part to crack or anything like that.
All right, Paul, hope that answers your questions. We have another question that came in from Benjamin. So what sort of tolerances do you tend to say we can expect?
So we say typically about 0.5%. So the larger your part, the less accurate it tends to be. But we do say your machines are very precise. So if you see your part is off in some X dimension, you can change that into your CAD software because our printer will print it the same way every time to get even tighter tolerances than that.
Okay, Ben, no, that answers your questions. I have another question that came in from Christopher. So Christopher has a question about waste. So he says that we recycle our aluminum waste. Is there a process for converting the supports and rafts to recyclable material?
Yeah, so all of the supports and raft are just going to be the material that you printed out of. So say 17.4. All of our rafts and supports will be 17.4 materials, so you can recycle them like that.
Okay, great. And then I have a question that came in from Andreas. What is the print envelope?
So our print size is about, or our build volume is about 12 inches by 13 inches by 8 inches. But we are limited right now by our Sinter 1. However, we are building a Sinter 2 right now that's going to be able to fit that entire build envelope.
All right, thank you, Kat. Are there any other questions that you guys have? Just go ahead and type them in. And so Benjamin has a follow-up question. So how big of a part does it fit in the Sinter 1?
So the build plate is about 9 inches by 4 inches. And so we have a round tube that is about 6 inches in diameter. But you have to think about it how it's a rounded tube. So the max height is about 4 inches. But it's rounded, so you have to hit that like top height in the center. If that makes sense.
Okay. And for those of you that are in Southern California, we do have a Metal X open house coming up next week on April 24th. And we do have the Metal X, the Sinter, and the wash here. So you can come in to our building and take a look at all three of the different components. Another question that came in from Paul. Do we have to calculate the size needed to handle the shrinkage, or does your software do it?
Nope, our software does all of the calculations for you. So you just put into Eiger, our software, what you want your final part dimensions to be, and then it scales it up about 20% in each direction. I was gonna say that's another thing you have to account for when you're talking about build volume. That's our max green part size. And if you put it into Eiger, Eiger will tell you the green part size as well.
Fantastic. And
And if I recall, there's a free trial on Eiger, right, Kat, that people can just log on and try the software out for a while?
Yeah, absolutely. If you ever wanted to try Eiger, you can head on over to markforged.com and go and try our software for free.
Excellent. There's another follow-up question from Andreas. Are there any residual stresses?
No, there shouldn't be any residual stresses. Because we're sintering it and cooling it down in the furnace, it comes out of the furnace in a near annealed state. Unlike powder bed, where you're rapidly heating and cooling the part, and that's where you really get your residual stress from, you won't really have that in our process unless you were to maybe take the part out of the furnace above the temperature that we recommend. But our furnace tells you not to do that. So.
Okay. And then I have another question from Jeff. Do your different metals require different design considerations?
The only really difference between like printing any of our metals is the wash side of it. Some of our metals are a bit more dense, so they will wash for a different amount of time. But some of the heavier metals also require supports at lower degree angles, so you may not be able to have that 45 degrees unsupported. So it is a little metal dependent, but for the most part, it doesn't really require any design changes.
Okay. And then we have another question from Ben. If we have holes/tubes not in Z that might not be straight, is it possible to get support out easily? Is there a way to tell to put the ceramic support or something in there so we don't get a metal snake stuck in there?
So for right now, we don't have an option, and that's where the design for additive really comes in. You can, if you make that tube like a teardrop and you don't need something perfectly round, then that is probably the route you want to take, so it's self-supporting. But we are playing around with options to allow you to kind of customize your supports to make them a lot easier to remove. So hopefully we'll have something released here pretty soon in regards to that.
All right, thank you, Kat. I think that's all the questions that we have in the queue. Again, I want to remind everyone, if you are in the Southern California area, we do have a Metal X open house on April the 24th. If you are in Houston, in the Houston area, we have a Metal X open house on May 15th. And actually, you'll get to meet Kat in person at that particular event if you go there. So to register, just go on to saratech.com/events-calendar, and then you can see the events there and you can register for it. So at this time, I'd like to thank you, Kat, for being a guest on our webinar today. Some fantastic information that you were able to share with everyone on here. I do want to remind everyone, when you log off the webcast, there's a short 5-question survey. Please just it takes about maybe 15-20 seconds to fill those out. It will help us out quite a bit in terms of content and future information that we would like to share with you all. And also, don't forget to follow us on social media. We do record all of our webinars and post them on our YouTube channel. So if you are not a subscriber, please log on to our YouTube channel. Just go on YouTube and search for Saratech, and you should be able to find us or use this link here and subscribe. And anytime we have a new content, you'll be automatically reminded. And there's tons of stuff on there you can look regarding 3D printing, PLM, software, tons of engineering content there that you can consume. With that, thank you everybody for joining us today, and hopefully we will see you on a future webcast. Thank you, Kat.
Have a good one. Thanks, Andy.